All right. Chapter 5.4. There's it's not a lot of problems, but it's a lot of information. So it could take several videos in order to get all of the information in. So uh, let me uh, This question is intended to give you practice reading and paying attention to the instructions that accompany the problems you're working. Use commas to separate your answers. Sometimes it asks for the real zeros. Sometimes it asks for the x-intercepts. They're the same answer. The problem is they look different. Okay? How you write them makes it look different. So -2, 0, and 2. Notice these are the three places that it crosses the, did I share this? Nope. Hang on just a minute. Okay. Yes, that's what I wanted to share. Notice it crosses at -2, 0, and 2. These are what's called zeros. But if you put it in as ordered pairs, these are called x-intercepts. Same information, but the look of them is absolutely different. So -2, comma, 0, +2. The zeros are just list them as x values. The x-intercepts are ordered pairs. Now remember, I've got the handout that tells you basic functions and their graphs. Y equals x. And instead of y equals, I've got it with the functional notation. Functional notation is f of x. Equation notation is y equals x. This is a line. Y equals x squared is a quadratic or parabola. Y equals x cubed, cubic function. Y equals square root of x. Shows up like that. Y equals a number is a horizontal line at that y value. I did not put that. I didn't put it in the handout, but it is something you need to know. X equals a number is a vertical line at that x value. Absolute value is a V shape. Y equals 1 over x is the butterfly shape. I call it butterfly shape because it kind of looks like a butterfly. Oops, let's go the other direction. That was a bit of a dyslexic moment. And then cube root of x. X cubed looks like this. Cube root of x looks the same except it lays down. Oh, and the square root looks like half of a parabola. Now, each of these this one, this one, this one, this one, this one, and that one all go through 0, 0, and 1, 1. Now, a polynomial is a smooth curve with no missing pieces, gaps, sharp edges, it is an equation containing only positive integer exponents. Another piece of information that goes with this is that it will pass the vertical line test. So if I put a vertical line anywhere on this curve, it only cuts that curve one time. Okay? Is the curve smooth? Yes. Well, this one passes the vertical line test, but it has a sharp edge. It is not a polynomial. This one has a gap. It also has a missing piece. So there's two situations here. It's got a missing piece and it has a gap. Will it pass the vertical line test? Yeah, it does pass the vertical line test. But it has issues, otherwise. Now here, The vertical line test is good. It's a smooth curve. Yep. No gaps, no missing pieces, no sharp edges. This one's good. So that one's good, and that one's good. Determine whether the function is a polynomial function, and if so, find the degree. Okay, so that means I need to explain what a degree is. Degree is the sum of exponents of each term, then the degree of the polynomial is the highest degree in the list of degrees. And of a term is the sum of. Okay, I should have said it that way. Degree of a term is the sum of exponents for that term. Then the degree of the polynomial is the highest degree in the list of degrees. Determine whether the function is a polynomial function, and if so, find the degree. So, if I say f of y, if I look at Desmos for this, okay, 2y to the fourth. That's all I'm going to put in. 2y to the fourth power. And I'm going to say x equals. Uh-oh. I don't need to put in the rest of it. I could put in the let me share this tab instead. There we go. Oh snap. If I put in x equals 2, how many times does that cut? It cuts it twice. Does that pass the vertical line test? No, it does not. So I could have put in the rest of this equation, but I didn't have to. As long as I see what this first piece does, I don't have to put in any more. So obviously, I don't really have to see any more. I can ignore this dot that's already there. Once I copied and pasted, that dot automatically showed up. So this is not a polynomial function because does it doesn't pass the vertical line test because this is a y to the fourth. If it was x to the fourth, it would be good, but it isn't. Determine whether the function is a polynomial function. Find the degree if it is. So we go back to Desmos, 1 over x squared. 1 divide x squared. Uh-oh. What's going on here? There's a gap. It's a smooth curve. It would pass the vertical line test. But the problem is, we got a gap. So again, it doesn't pass. It's not a function because it doesn't pass because we got a gap this time. So we don't have a problem yet, so go page next. F of t equals -4. Let's go to Desmos. -4. And we got to do y equals -4. Hey, that one works. Okay, that one does work. If I bring any vertical line in here, x equals 2. Let's say -2. Well, let's say -1. It doesn't matter where I put that line. It's always going to pass. Now, remember this, okay? This is the same thing as and this was from chapter 1.6, I think, when we went over exponents. Or maybe 1.3. I don't remember. Anyways, that was way too long ago. So this is, and it is a degree 0. Now, this is an x in here, so that's good. And that's a whole number. So this is true. And the highest number is 5. Ooh. Excuse me.